I had the privilege tonight of sitting with this fine young gentleman over here, and so anyway, I shared with him in my previous life, I used to be a wholesaler. So, anyway, thank you all so much for coming, not only the symposium, but for the dinner tonight. What a great time. I hear a lot of conversations going on, which is always good. It's a great opportunity to get together and share life, share experiences. So thank you for that. Tonight, we are honored to have a guest that I learned a little bit about him when he worked for this little company called Nano Avionics as a CEO. And when I finally got to see his bio, I was like, oh my God, he is somebody important. So I knew it was great to have him here, but now I'm even more impressed. So, Brent, if y'all haven't had a chance to meet him yet, he is, now this is the fancy title, CRO, Chief Revenue Officer.
Oh,
Yeah. No, that's a revenue. People from North Carolina and Tampa area, Tallahassee area, they know about revenuers. Anyway, he's a Chief Revenue Officer for Rogue Space. And he's been there since 2022.
20, yeah.
July, it says right here, July 2022. Okay, I got that right.
It's written.
So it's a fairly new company. Of course, most stuff to deal with space is new, especially the newer stuff. We have the old standards, but a lot of new startups and stuff. But he's been doing a great job over there at Rogue Space. And if you haven't looked them up, do yourself an opportunity to look them up afterwards. They're doing some really incredible stuff, which I'm sure he'll share with us tonight. And as I mentioned before that, he was with Nano Avionics, where he was the CEO. Now, Nano Avionics is actually over multiple countries. Lithuania was their primary source there. So he was the CEO of the U.S. Company. Before that, he worked for North American operations for Clyde Space, AAC. And then before that, oh my goodness, Surrey Satellite Technologies, US.
Hey. Oh, all right.
Started a payload program at SST US with the world's first all-commercial hosted payload satellite, OTP, orbital testbed. Prior to joining Surrey, he served as a business development manager at Honeywell Defense and Space and invented their miniature momentum control system using control moment gyros. So when you're done with Rogue Space, I'm sure engineers will let you volunteer for them too as well. Let's see, he's been a member of AMSAT and is a member of AMSAT and has been a radio amateur operator since 1992. So sit back, enjoy the ride, and I will hand the mic over to Brent.
Thanks, Harvard.
Thank you.
Let's see if the computer stuff goes right for me. Sorry. This young man helping me, so I know I'm good.
Yeah. Yep, speaking. You have some paid for the Bolton check. Swallow one button.
You gonna come on?
You know, it may be that it is, it may be, we gotta do the lights. All right, I'm gonna turn off the,
Pretty well focused.
Yeah.
I'm sure that this is the focus.
Whenever. Yeah, whenever you're ready. it was an honor to be asked to come here, and it gave me the great opportunity to come attend one of these also. I hadn't had the opportunity before. Really enjoyed all the papers and stuff too. That was half the fun of volunteering and listening to what's going on in two of my favorite worlds, which is space and amateur radio. I thought Andrew asked me to come and talk about rogue space and what we're doing, and there's a lot of similarities, I think, between what we're trying to do and how we're a small company being pragmatic and amateur radio and amateur satellite radio as well. Oh, can you hear me, or do I need the microphone? Use the mic. Use the mic. Okay. All right, there we go. All right, sweet. So I thought tonight, in addition to telling you about what Rogue's doing, it's a new space company, a lot of fun things, and it's fun. And they, chief revenue officer, and responsible for bringing the money into the company, and also enjoy systems engineering as well. So I never quite got away from my engineering background, so I'm glad for that. But I thought I'd share. Again, it'd be a ham, someone asked me the other night, and if I could share that with you, and then have a section on thanks, and then a little bit on Rogue, and then a question, an invitation, general invitation, and then a question answer if you have questions about me about anything. But I thought I'd share how I became an amateur radio guy. How many, someone talked about the Radio Shack the other night, but my cousin gave me a science fair 10-in-1 Radio Shack kit for Christmas one year. That was it. I was going to be an electrical engineer. That was it. So it was all over. Got the bigger kits, did the crystal radio, threw the wire up over the power line coming into the house. You know, should have been dead a couple of times, but that was it. I was going to have fun with that. The problem was putting things together and not knowing the theory or the way to troubleshoot it when it didn't work. Trying to put that together again. But so that led to, and I've always been interested in ham radio, but there was really didn't know any Elmers, so we kind of needed an Elmer to get going. And but anyway, in about fifth, sixth, maybe seventh grade, I was printing my own printed circuit boards from the Radio Shack kit with the ferric chloride and the traces and stuff like that, and then using a 16-inch drill bit to make holes for ICs. It's just amazing anything worked. But my mother was always encouraging me, and she'd go to Radio Shack, get me this or that. And I got away with a lot of shit as long as I call it an experiment. What are you mixing in the drain? What are you mixing in there? Oh, it's just an experiment. I got away with everything. She'll say that. But then let's see. So after that college, but my first job out of college was working for a large or for a small company that worked on control systems for large ground stations. That was they had a couple of hams there that kind of encouraged me there too. But they had one of the jobs I worked on. It was for a Goon Hilly site. One of their antennas there. I don't know which one. We're trying to figure it out the other day. But it's basically 2 or 4 30 horsepower DC motors, one for each axis, for a 32-meter diameter dish in the Rift Valley in Kenya. We went out to install that. So I just like think of all that for gain, right? I had the British Telecom made that antenna, had 2 elevators in it, and that was fun. But I forgot who, but in college, I did 2 internships with a company most people recognize, Rockwell Collins, at Cedar Rapids, Iowa. And a lot of hams there too, and worked in their antenna coupler group, and then I did a power supply design for one of their aircraft radar systems for Starship, which was a failure of an aircraft, but it was a great thing. I finally got to fly in one of those eventually when I was working for a at the time. Hams there, of course, especially in the coupler group. Everyone was a ham. They had high power amplifier group, so always a lot of good encouragement there. But it wasn't until I got to Honeywell in their radio group. They were aircraft avionics, business jets mostly, general aviation, but mainly business jets. And a whole crew that I was working with, radios, transponders, weather radars, was great. And finally had the Elmer critical mass to help me get my ticket in '92. And what's nice, you're electrical engineer and stuff like that, you can take, 3 tests at once at a big volunteer exam, anything up in Fort Hill, Arizona, was up in, by Flagstaff. It was always great to get out of the valley in the summertime. And then, eventually, when I got my speed up, I finally got my 13 words per minute to get the extra at that time. So I was waiting, came down to 13 from 20, and I thought, okay, better do it. I didn't know it was gonna go lower, I would have waited. But, yeah, I am NA 70. Favorite thing in Arizona was with the Honeywell group. I usually head up the field day group. We get out of the valley in summertime when it got to 110. June's usually the hottest time of the year. And we go up on the muggy on rim and then big trees and string wires, and everyone had a new contraption for putting a wire up in that big long wire system up in that in the Ponderosa Pines, and it was great fun. We went about contesting. Fell in love with 6 meters. Band was open one night. We were working into Japan. I remember one time we were just like copying from the CW, and just I'm getting JA. And I go, that's Japan. That's pretty cool. Working FM up in Alaska was fun. So I've always enjoyed the Magic Band at 6 meters. So it's good guys. And I bring up Elmer's because it's a big thing and a big thing in life. I also compete in the Scottish Highland Games, and there's not a lot of manuals on how to do that. So it's a great fellowship, like amateur radio, like AMSAT, stuff like that, where you get Elmer's to help you. And my wife and I help train people, don't be afraid going into it if you're ever interested, kind of thing. So the Elmer tradition, we try to pay it forward, and it's been rewarding of its own. So we really enjoyed that. So I've always kept track. I remember watching with Ernest because I was working with Honeywell and they make reaction wheels. And AO40 was coming up, and I was watching that. And they had someone at the Tut Hill AmFest who was associated with AMSAT group, and he was telling me about that and the reaction wheels. Because Honeywell had to look into magnetically levitated reaction wheels, but they had trouble getting the stiffness out, and they didn't work on wheels, but we were hopeful. So we're disappointed, and I can't imagine the disappointment with the German guy who never got to turn those things on. We're disappointed too, but that was a great program. I remember seeing that was in QST on the front page and all that kind of good stuff. So I was finally glad to connect up with AMSAT, when I was at Nanoavionics, try to look for something we can do together. So I like to contribute and do something that's mutually beneficial all these years. And so we kept in touch and all that stuff. So it's good. So before I get into talking about Rogue, I was reviewing the history of AMSAT and things like that. And like Surrey was a big deal in small satellites and stuff like that. But I can't believe how far back amateur satellites went. It was, they were the obvious pioneers in small satellites. And practicality, pragmatism, getting extra rides, getting extra scrap, putting stuff together, guys coming together, getting critical mass to put something together that only big companies can do. It was the jealousy of Telstar spending millions of dollars, trying to get their stuff out. But not only that, the one thing I didn't know that surprised me was rideshare. And rideshare is now being such a big deal. And if you see, SpaceX is every launch, they make a transporter, which is like a Christmas tree to 100 or more satellites. That's full rideshare satellite or mission dedicated to that. It's been a huge boon to the small satellite industry or people using small satellites to get into business. And it started right here with guys like you. So I want to say for like new space companies like me that I've been involved with, I was a big space with Honeywell. Got into small space, Surrey, never looked back. It was great. And it was people like you who put this together, the history that got it going so that we can make a business out of it. Sorry, I'm not holding that up as much. So that's my thanks to AMSAT and AMSAT mentality, the pragmatism, the Elmonism makes companies like us, 25 people putting up a satellite. We've got 2 more planned. It makes it possible. So thanks. So Rogue is a company that started in 2019, and I got to know them because they were coming to me for nanosats while I was at Nanoavionics. And after I had started up their office and got them going and stuff, and my contract was done, Rogue was like, you want to come work with us? And it was guys that I knew, I already worked with, and knew what they were like. fellowship was there, the culture was there. It was one of the few companies I'd seen that worked on culture as much as technology and success. So I thought, it's great guys to work with, and they have been ever since. So straight through them all, pick them as I got to you. So Rogue is a company they first got started because they wanted to clean up space, get junk out of it, and things like that. Now they still want to do that, but they realize that's a hard business case to close when no one's paying. So they pivoted from space junk to logistics, trucks, transportation, service, fueling, observation, space domain awareness. And it comes down to, we're going to make robotic satellites that were remote control, could do rendezvous, proximity, and operations around other satellites, could provide hostings for people to either grow new human organs in space, new pharmaceuticals, want to see if their new telescope works in space, new instruments, or just get heritage because they make subsystems that need to prove themselves in space before they can sell it. So a big part of our business right now is putting up satellites that help us on our roadmap to make robotic logistics supporting satellites and also do hosted payloads. So at the front end, we have big grandiose ideas, but it ends up at the end with some type of station or place we can put hosted payload to host radio repeaters, telescopes, other things like that in space. Supports in space manufacturing and assembly, or anything else that needs to be in space in a very cost-effective way. So we'll need robotic spacecraft that can move around, have a whole lot of delta V, and there's some great things that are coming up in that propulsion area these days that I'll talk about that are very interesting. And then we thought, well, we're going to have logistics. We need storage containers. So we got a small, semi-capable small satellite. It's a CubeSat, but it's only 20. It's like 27. We're going to standardize. We're going to pick it up, put it around, move it around as needed. And we've had our first satellite up in last year, which was just a simple 3U. Just kind of straighten out our mission operations, see if we could get things going, and we got it up and flying. We went with EnduroSat for the bus and got them to fly payloads. The interesting thing about this is we had our first commercial payload, which from a company called IVO. They have a propulsion system they claim uses quantum inertia. It's basically apply power and you get a small amount of thrust out of it with no propellant. It would be I'd be revolutionary. They tested in a TVAC on the ground. They haven't tested in space. Most people still don't think it's going to work, but everybody hopes it will because it would be revolutionary. We use power and move around as needed. It's infinite delta V. Well, the satellite only lasted a couple of months because it had a power problem and we didn't have redundancy in it, and so we lost it. And I always like to raise this funny specter because it's true, but we don't have any way to confirm what it implies. Is that our last contact we had with Berry 1, we call it Berry 1 because there's a bat in our old facility that they kind of kept track of and fed and stuff. So we called them Berry, so they call it our first Berry. And Berry 1, right after we had our last contact with it, we got a conjunction notice that we were going to be, I think, less than 60 miles of a Chinese satellite, and they crossed, and we were never able to talk to our satellite again. So I like to always hang that specter out there that was, who knows what happened. Anyway, but we pretty much think it's the power system. So our next satellite's going to be, it's not on here, but it's going to be an 8U. It's going up in February. So we're giving Evo a free ride because we weren't able to test their system, and everyone was waiting, including them and the world, to see if you can do propellantless propulsion. So we got it into 8U. We got our one other of our payloads is a scalable compute platform. It's edge computing we kind of made for ourselves because we knew we were going to be needing AI, autonomy, machine vision to be able to do rendezvous and proximity operations safely. So we knew we were going to have a lot of computation and algorithm needs. So we developed the SCP. We flew that, talked to it a little bit, didn't get to really exercise and stretch its legs, so we're flying another one. It also has the next one flying, and it's not Berry 2, it's we're calling it OTP 2. It's going to be flying on Tom Transporter February. It has 6 cameras connected to it, but one of them actually is looking inside, so I'm not counting that one to help with the vision stuff. And we're hoping that this satellite not only will fully test out the 4 hosted payloads that we have on there, but also serve as a cooperative object for our next mission OTP-3 going up 2026 to go dock, or not dock with it, but to come and do rendezvous proximity operations. And when be friendly, and we don't have to worry about registrations and legislations and things that keep us from approaching other people's objects. On OTP-2 launching in February, we have EVO on it, the propulsion system. We also have a new one they just flew. It's called Milespace/Rocket Star, depending on which lawyer you're talking to, because they're having issues. But it's a water-based, and there's been water-based stuff system before, but this is a plasma water-based. And for electropropellant systems, it's got the best performance for very low power on the market. Heads and things like that can't compare with it. And they've tested it in the lab stuff, and it works. And they go forward. And they tested on a deorbit spacecraft, and it works so well. It spun up their spacecraft out of control. They're trying to get free control of it. They couldn't put it on, make it a translational propulsion, so they put it on the side and said, okay, you turn it on and we'll figure out how much it spins up the satellite. And unfortunately, their ATCS system didn't like the rate at which it spun it up, so they're counting that as a win. Anyway. So we're going to have them on board. So this 8U satellite will have quite a bunch of Delta V if some of this works. Let's see, what's the third one? Oh, there's an encryption system. They call it quantum oxidor encryption, but it's the size of a credit card. And if anyone's ever had to worry about getting a satellite, put encryption on board because it's with the DoD or something, it's a piece of equipment that limits the smallness of what your satellite can be. And this is a credit card size one, so they're paying us to fly it and do a demo on that, and then they can go to market. The fourth one, again, is our scalable compute platform, our edge compute, which will have all the cameras, and we can do that. I've even got some customers that want for us to fly their AI algorithms, so we can upload it to the satellite, and they can use the sensors, effectors, cameras to do whatever they want. We keep doing that. So we call it a maskless hosting. So you're instead of sending a piece of equipment up, you're sending software up to test it. And that's a lot simpler and easier than testing hardware, especially after you've launched it. So that's going up February next year. And then OTP-3 is going up in 2026. It will be significantly larger, roughly about a little less than 200 kilograms. And because if it gets heavier than that, then my launch costs go up dramatically. And that will be a 4-point or ring launch. I'm not sure we'll do directly with SpaceX, where these other ones with the nanosats we've done through Exo Launch. They're really great people to work with. I don't know if you've ever worked with them, but they're really great hands-off. Recommend them. So OTP-3 will be our first step towards rendezvous proximity operations. It won't have any grabbing capability, no robotic arms, but it's our next step to get that to the next satellite. It'll have a sensor array for very close, medium, long term. It'll have LiDAR. Some of the technology where we're using that for LiDAR for machine vision to characterize the shape of a spacecraft so that we can model it internally. So it's spinning, when it's spinning at, it's safe to approach. Is it something we expect or something we don't expect? If the DoD wants us to go take a look at something and characterize it visually or radiometrically and see if we can look at it. So it'll have RPODs. Also, half the spacecraft, if not more, has been reserved for paying customers. One of those is customers paying us to fly a remote sensing telescope that does 1.5 meter spectral ground imaging. So that helps pay the bills. And that's why we're trying to stay as bootstrapped as possible. We've got investors that want to go in, but we haven't done a serious raise yet. Love to have the money to do a bunch of stuff, but it's nice if you can just bootstrap yourself up in a small market. I mean, there were times when we were going to be ceased to exist in about 2 weeks because we had that much payroll going out. And that's the shape of a small 25-person small satellite company. But we've won a bunch of SBIRs. For those who don't know, it's Small Business Innovative Research from the Air Force and Space Works. And it's not only given us a good amount of money to keep our runway out further and do what we want, it's given us great technologies. And I was going to go over some of those because they're really fun and interesting. Look forward to implementing them in space. Okay, so OTP is going to have that. It's going to have an array of CMGs on board. We're also putting on the Blue Cube laser gimbal system. So it's a laser comm system. It's a smaller system. It can go satellite to ground, and it can also go inter-satellite link. There's a company called Neuron who's paying us to fly it because they have another satellite that's flying the system in order to demonstrate the laser crosslink in space. Now, this is the kind of hosting we really like because this enables our roadmap. When we're up there doing real-time operations and getting in close to another piece of equipment or another satellite and grabbing it or looking at it, it's great to have near real-time, high bandwidth communications that you can't get with RF and even when you're over a ground station. So we're really excited about having that capability and testing that out for the customers as well as he's going to get up his constellation so that we can be 24/7 communications with our satellite once he's got his system up. Because as long as I can see one of his satellites, I've always got linked to ground, and it's going to be a huge boom for us. Plus, it's the FCC out of our face. I don't know if I haven't heard anybody talk about regulations and stuff, and I know you have frequency allocations, but that is the biggest pain to a commercial company is getting the certifications done in a timely manner so you get satellites up in a timely manner and go on stuff like that. So I look forward to it for several reasons. Plus, it's going to be fun. And it's easy to make a telescope on ground that can receive it versus an RF system on board. Just got a point telescope, a decent sized telescope with a way focal plane on it. So that's OTP3. What else are we going to put on board there? It's interesting. We're going to sell up the space on that, about 70 kilograms of paying customers to help us fund the satellite going forward. And the nice thing is not only demonstration, but also operation. The telescope has been flown before, but don't worry about that. The customer has customers, so we get a revenue stream from them by flying there. So that's kind of the logistics model that we're looking at in the long term, except we're just doing it on the satellite this time versus big satellite, which is a ways out because I'm sure everyone here can imagine what it's going to take to design and pay for and build and launch that big thing off the right, which we call Waypoint. But we'll get there. So that covers some of the things we're going to try to do. Let's get back to some of the technology. Just to get back to this is one of some of the discussions we've had before. I was at Nanoavionics, and so we've got a bigger satellite, we've got some space on it. So we're going to try to explore potentially rideshare hosting transponder or something like that, and figure out how it was night. I'm only one member of the leadership team, so I need some help selling it, internal to our, and there's so much expertise here. That for things I was thinking about during the last 2 days was, God, wouldn't it be great to have some of these guys in on our design meetings? We got a pretty young team. I'm the most space experienced guy in here. Did pull on a new 2-star general who's our COO from Space Force. His general knowledge too, but hands-on. There's only a few times I was allowed into a clean room to help test something together that usually otherwise made me keep my hands in my pockets because I was more BD by that time than engineering. The design review, engineering review, but also I was talking with the crew. I go, could we make use of a transponder or whatever you were going to host on there? It could be an alternate way for us to get GPS down if we can't, we lose contact with a satellite. just looking for a, nice trade, what's a win-win for both, and stuff like that. So good thing is I'm the AMSAT champion inside our group. So you know someone, right? And so we're going to look for continued ways to work together. And that was the part of the invitation at the end of this. So we talked about some of the technologies we're developing, and autonomy is one, sensors for close, medium, long range, for approaching things, keeping track of what's in space and categorizing it, being able to derive ephemeris from something crossing over your focal plane, 6-degree freedom, capability, propulsion, RCS needed to move in 6 degrees of freedom.
Now you're on the screen.
Sorry.
Right there, so.
I did it right here.
On that. Yeah. Sign here.
Oh, yeah.
Yeah, no NDAs, but I did take most of this from one of our investor packs, so I had to cut some things out. Yeah, so sensor processor, data fusion, we still got a lot to do in IA, artificial intelligence and things like that, coding and stuff. Edge computing, it's the only piece of hardware we made ourselves, just because we knew we were going to need something different than what was on the market, and takes advantage of NVIDIA, GPUs, and things like that. We want to make our craft reusable. The OTP thread I forgot to mention, we're putting a docking port on it, and it's a company called Spaceworks, and it's gonna be a grappler port, and it's gonna have electrical contacts, so you can discover and say that my satellite went bad, you can go in and charge up the batteries, and it has a fuel port. So we're going to be using that Miles Space / Rocket Star for water propulsion. We're also looking to use it as an RCS system, so we get a 6-degree freedom, and then we can refuel water in the water tank to get the full capability. It'd be the first spacecraft to do something like that. And what's great is it's a green thing versus a hydrazine or a bipropellant or something like that. So that's going to be a big thing for us. I think we're going to make big headlines with something like that. So we want to make it reusable, just like I said, that it only make them, because the Delta V, being able to get to people who need help or over here, different orbit or something like that, and you need the Delta V. So you can only go so far with just using this Miles Space. It's great, it's the best in the industry. It's going to run out. Need to be refuelable. There's nothing else to it, and that's one of them. So we got to make it refuelable. We'll probably be doing part of our own logistics and infrastructure. There's companies like Orbit Fab that want to do refueling. They're not looking at water right now, but maybe they will. So maybe they help us where we have to help ourselves. Multifunction craft, it has to be capable of doing stuff for other people, or hostings. That's right, to do by our business model. Standard craft and neighborhoods in space. So if you have something you need to be in space, you need to be growing something, building something, returning something. We're also looking at partnerships with down mass companies. There's a lot more down mass companies coming out now that can bring stuff back. And that's just where we're going to partner. We don't need to be doing that. There's a lot of interesting companies right now that are getting good in that area. There's a quick chart to show you some of the things we're talking about. And we have our tech that we're trying to develop on our roadmap. I'm shooting myself. Sensor hardware systems we talked about, LiDAR and radar. There seems to be a lot of interest if we are going to go by an unknown object to characterize it in any way possible, either color, optical, radar, infrared. Anyway, seems to be of interest, RF wise. We not only have a LiDAR system in our near little cameras, we also have a project that's been phase 2 funded. It's a laser vibrometer, and I have heard of that before. It's not new tech, but it is in space. We'll shine a laser on a satellite up there, and we'll be able to tell how it's vibrating. If it's mechanically vibrating, is it a live satellite? Is it a dead satellite? Are the reaction wheels spinning? Are mechanisms working? We can also pick up vibrations of the switching power supplies off of any of the components and stuff. So we can tell if it's alive. And not only that, I thought of an internal use is that we can characterize our own satellites when we're on the lab before we launch them and see what the characteristic vibration signature is. So that if we're up there, we can say, well, there's a satellite. Hey, it's not really vibrating in family. You know, that looks like one of the wheels is going bad or this or that. So anyway, it's a lot of fun. And the LiDAR we're using to get a 3D picture and characterize what a spacecraft is doing. And it's pose, I guess you call it, how it's rotating and things like that. Some of the autonomous AI stuff they want to do is in here. I'll go into depth on some of that. The SAMRIC is just a way of using different optical sensors, different bandwidths of characterizing anything that comes across. Say we're staring out here, we know what objects we should see. Something comes across, we can characterize it in whatever spectral band, put them all together and figure out what the order of that going. If it's going somewhere, is it accelerating? Is it decelerating? Or doing something funky that's not in the catalog that people on the Earth come to depend on? Let's see what else. Rust, I have to look up and remember what that is. But I think this is the one that uses the LiDAR data to give us a full picture of what the object is that we're looking at. Propulsion, I already told you, this, one of the benefits of hosting different new propulsion systems, we get to test them out ourselves. Is that, you know, propellant stuff, does it really work? I think I'm the only one in the company who thinks it could work, but everybody wants it to work. It's like, boy, we'd just be in the total business if that thing worked. I mean, we didn't have to have propulsion, we didn't have to refuel. But anyway, also we're looking at multi-mode for if that thing worked, and then we could use that for reaction control as well. And the water system's looking pretty good. Omni-magnets is something we'll go into. Basically, when we get our fourth spacecraft, we'll likely have the arms on the Espa Grande size, which is around 300 kilograms, around that area. And it's so that we can go up and reach out and touch things, as well as not just go rendezvous and proc stops, but in rendezvous and proc stops and docking. But as we all know, the relative spin rates and attitudes is just things we come close to, or they're not going to be zero, you know, rates with respect to each other. So this is a technology that was developed by a doctor that was going to move things through the human body using magnetic fields and moving it through space through there. We thought we want the space version of that. So now we're getting on our phase 2 to develop that so that we can go up and put our arms around an object, and depending on how big our arms are and how strong our magnetic field is and how much we want to put power into it, how much power we can dissipate, and not make them just giant magnet torquers and throw us, you know, off kilter, but go in and stop the relative motion of the object that we look at, so that we can either look at it very clearly and inspect it, or make it safe so that we can grab it safely with respect to the spacecraft and stuff. I think this is going to be a big differentiator for us in the future. And the next stage after the phase 2 is the main prototype that we can take up, hopefully, with our fourth spacecraft, hopefully not too long after 2026. We already got a customer, commercial constellation customer wants us to go up and take a look. He's got one that didn't, soil didn't deploy anything, so we nudge it, do this, that you can get it operational again. I go, if nothing else, it's a great science experiment. And I wish I had one of those things. I wish I had one of those out in Geo right now, picking up some of the garbage that was just. I bet you someone might pay for that. But anyway, I don't have anything up there right now. Nothing goes as fast as you want it to in space. Sorry if I'm not doing good with mic management. Just tell me and I can talk louder. Okay. One of the things we just fell into that I thought I'd share is because when I was at Nano Avionics and we were these guys, they were getting a free launch from Air Force. And the Air Force goes, okay, we're going to fly your LoRa spacecraft. 12 of you are supposed to have 6 degree of freedom capability. And they go, oh, are you tabbed or railed? And does everybody know a tabbed or railed nanosat? So deployment systems, your spacecraft has rails that it rides as it goes, deploys out of a deployer, or it's just along the 4 rails of the corner of the spacecraft. And never the two work together. And it depends on which manufacturer you go to. So they have the dispenser all right. They go, okay, we'll give you free ride, but you got to pay for a new dispenser because yours isn't compatible there. So I'm like, it could have been nice to know that a little earlier. So as part of the Silver phase 1s, they said, okay, we're going to just throw in there this idea of making a dispenser that handles both, and think that the Air Force would like that. And fortunately, they did. So they ordered phase 2, and now we're doing phase 1, and now we're doing a phase 2, and we're doing it with the University of Illinois. They've been great partners for us, so that we can make dispensers, or likely we'll probably license it to dispenser makers. Say, hey, you do this, and you don't have to get chosen one way or another. And so that's fun. It's the pragmatic side of things. It's not like on a roadmap thing, but you know, if we can make money licensing it today, that's great. This is the Omni magnet, touchless detumbling. They did some lab tests and dealing with spheres and stuff. And it's not magnetic, it's inducing eddy currents into conductive surfaces within the spacecraft. So aluminum panels and things like that. If you vary the magnetic curves, I work for a Honeywell group that made eddy current dampers for deployment of solar arrays, right? You run a strong magnet over copper or vice versa. It just slows it and it slows it out. But yeah, so it's looking good. I can't wait to get those things flowing. I don't look forward to seeing the power budget needs for something like that. But get out Dr. Evil and give me some big batteries. This is 3D ROS, and it's using the LiDAR to characterize and shape it. It gives kind of machine vision of the object we're approaching. Gigabit multi-host sensor bridge. Basically, we're getting tired. Engineering gets tired of all the different, IC2s, space wire, this and that. And they proposed this and got it funded. And now we've pulled it into our bus, so that we're going to make a bus that's our e-bus, so that we can put in anyone's sensors, effectors, whatever, and it doesn't matter if it's this, that, or the other thing. It just makes it play together well. Uses Ethernet to the biggest expense possible. So we're on a phase 2 to implement this, and it's great because they're paying for us to do our future spacecraft bus design and things like that. Helm AI, this is we knew we were going to be using electropropulsion because we knew that Delta V was king. Energetic's great if you have to get somewhere quick or you have to avoid a collision or something. So they're paying us to help develop algorithms to get to places cost effectively and saving fuel with electric propulsion. This is the laser class, the laser vibrometer we told you about. I said, I want one now on the next spacecraft. And they said, we're going to build a flight one. I go, oh, wait. And this is the SAMRIC, which was the using multispectral sensors to help characterize stuff flying in front of you that you either expected and you're confirming the orbits, or you didn't expect and you're going to report what the ephemeris or flight characteristics of the object is. This is our scalable compute platform. So we're going to be flying. Actually, we won the first one, put another one on the OTB2, and we'll have a larger stack on OTB3 to help exercise those. Give us that platform we need to develop our RPO algorithms out in space, and for anybody else who wants to fly with us. Astra, this is one where I think we just won this with another phase 2, where it's a step into our autonomous and AI software, where we share goals with the spacecraft. He has to be power positive. He wants to go look at this object. He's got to avoid trash. He's got to do this. He's got to, someone here has an interrupt, wants me to go look at this kind of things, and it shares all these and tries to optimize all these conflicting goals based on what we've told it. So we're going to try to develop that and fly that in the future. Just basically trust the spacecraft to do what's best, not crash into stuff, and achieve its goals. And look forward to AI. We also talked about putting a chess game on board so that people on the ground could play chess with satellite. But we'll see what that. It sounds like a silly BD thing to do. But reverse GPS. This is something we're exploring to see if DoD was asking us what to do in a GPS denied environment. And one of the concepts we had was knowing that there's transmitters on the ground of all different types, whether they're beacons, intermittents, or whatever, you can characterize through several orbits, teaching AI or something like that. Depending on signal strengths and things like that, that we might be able to get a general idea of where we were in an orbit around Earth if we had a GPS. this could get us in the ballpark. It's not accurate to everything, but we like the idea, so we're looking into that more. There's Carnegie Mellon University. It's also to do optical math. We're going to get some pictures from OTV2 of the Earth, different attitudes and stuff, and they're going to try to work on algorithms to figure out where you're at on the around the Earth, by the size of the Earth, and what's looking at, things like that. Optical math is going to be really important for us, I think, in the future. These things are all LEO, but we're all planning and making them ready to go out GEO. The businesses for clearing up space on these big, expensive spacecraft, where people want to look what's next to their spacecraft that they may not, that may be unfriendly. And then cislunar. So we're planning to be out in those areas. And so I'm throwing that out to Drew and the crew about what could we do out there in AMSAT on payloads in those areas. So that covers Rogue, and I ready to take questions and stuff. And I'm sorry if I went through it kind of fast. You can catch me anytime. But so I want to throw out an invitation. If think of ways we can work together, that benefits AMSAT, that can show benefits my company, we'll look for it. I mean, we're only 25 people. So we could use expertise, we could use help across the board. I know we don't have any resident radiation experts on electronics, so we definitely like to look for hosting transponder or something like that, and do something together to help us as well as them. And the eldership and the camaraderie in our company just reminds me of the fellowship that we have in AMSAT, amateur radio guys. So I think with both of us looking to try to do something fun, and I've always wanted to benefit AMSAT myself, that it'd be fun to explore that. And you guys have a tremendous resource in your crew, as you can tell. So it's an invitation. Think about ways to work together. Cislunar, GEO. He was just salivating about GEO the other day, and I was like, okay, well, this is not good.
Anything above 600 kilometers makes me drool.
Excellent. So then with that, just leave it open for any questions. Yes, sir.
Notice on your last slide, you had Bell listed as one of your clients or whatever. What is their interest?
At that time, and we're not working with them anymore, but they were on the first phase one stuff. They wanted to get into space, and they wanted to help us. They were looking at setting up a satellite integration facility for us, because they had been in space in the past, and now everything's helicopters, but they wanted to get into space again. They're fairly close by. So they were had a huge amount of aerospace engineers and resources and stuff. But the big company thing it didn't quite get through.
So I love that when people talk about refueling and how they want to refuel satellites. Is there any initiatives kind of like the international spaceports or docking stations going on for designing those refueling,
The only
together?
thing, yes, the only thing that's been going on so far is the Air Force has been trying to get refueling for hydrogen, and they've awarded one contract to Orbit Fab for hydrogen refueling I think it was in GEO. May not happen. I don't think they can pick up the slack and get there fast enough. The Air Force is looking for that themselves. They've also, Northrop Grumman, have a standard refueling port.
Yeah.
Orbit Fab, yeah, so they've got one, and for some reason they didn't want to share the information with it, even though it's supposed to be public domain. Orbit Fab has one called the Rafty, and they were almost giving them away. They were giving them away, but now they're charging for them. The problem is that you have to use their service to be refueled, and so they don't share the design of the grabber refueler system. So that's one of the reasons why we're kind of going our own way until it's more standardized. And we're not looking to be in the fuel refueling business, but we got to do it for ourselves. So we got to do it somehow. Does that answer your question?
Yes, thank you.
Okay.
Have you looked at the study that AMSAT did with GPS on the A40?
No.
Frank Bauer did a really good study on using GPS outside of the GPS constellation.
Yeah, that'd be good, because we're going to get out to GEO and we want to use it every point we can out there. I know it's usable and even potentially past the GEO thing. And the receivers for those, I haven't found any cheap ones. So Maybe you guys could design one that we could use. That'd be awesome. No noise, cryogenic. The other, yes, sir.
Okay, two questions, if I may. When do you expect to be in Geo, get to Geo, launch Geo, and when would you like the transponder delivered to?
Okay. 2027, and we need the transponder in the middle of 2026.
Thank you.
Yeah, we got it on film.
Yeah.
Yes, sir.
Your laser ranging, we were talking about vibration. Are you going to be doing any, variable frequency lasers that possibly would have?
No, we won't, but we want to do spectroscopy with some cameras in the future. We've looked at some, we haven't baselined it yet. So that's gonna be a single, wavelength, laser. I'm not sure what is, I think, whatever red is, that 540.
You know, JPL has done some stuff with variable frequency lasers.
Oh, okay.
And they're trying to identify some position on satellite surfaces.
Yes, we're gonna try to do that, but probably with multispectral optics, if we get enough light. But that's interesting though, because if we're in the dark, if you're in the shade, you can use that. Yeah, I can see how that would work. Think about it. Anyone else? Questions? Thanks, and I appreciate again. Thanks for the invitation. It was an honor to be here. I hope it was an interesting thing, and it was great to finally meet up with all of you guys and keep up the great work, because we're the pioneers.
But let me ask for another round of applause for Brent. What a wonderful.